ฮัลโหลค่ะ
สวัสดีครับ
สวัสดีค่ะ
Good afternoon, everyone, and good afternoon for the people who are watching us live on Facebook. Welcome to MuSpace Virtual Live event. In this event, you will get to know more about our satellite technologies and dive deeper into the technology that surround MuSpace. Moreover, we're going to show you the whole process of how we manufacture our satellites. I'm Green, and Prel from media teams will be your host for today.
Right. Our event will divide it in two parts. In the first part, our CEO and CTO, Kun James Warayut Yenbamroong, will unveil the MuSpace satellite technologies. And the second part of the event, we will have a Q&A session in form of a panel discussion. Before we start, Kun Green, can you tell us more about MuSpace?
Right. Now, MuSpace, we focus on manufacturing our small satellites, and the project is being spearheaded by our team with over 100 engineers. And the company now has 2 fully functional factories, and today we are standing here inside our third factories.
Right.
And Kun Prel, we are the only company in Southeast Asia that has our own factory to produce satellites. And today we're going to show you the process and the usage of these factories.
So let's not wait any more time. Please welcome the CEO and CTO of MuSpace, Kun James Warayut Yenbamroong.
Thank you. Thank you, everyone. Well, welcome for our friends over a social channel, and thank you for your continued support. Well, today I'm just going to be speaking in English, but if that's a request, we could do Thai session. Well, yeah. So today we have visual live. So the reason is to have the audience over the social channel, and I would like to welcome them to this session. So the main topics of today, it's obviously we're going to unveil our satellite that we've been spending time working on, and the other one is also the production scalability. So as Grin mentioned about, this is the third factory, so everybody is standing on the third factory. But in the past, we've been working on the first factory we call Factory Zero since 2020, and throughout this year we've been working on the Factory One, which is also now online. Yeah, but before we deep dive, before we get into that, I just want to recap a little bit about MuSpace. MuSpace, our mission is to I started MuSpace is because seeing the depletion of the resources on Earth, and also the overpopulation. We have population continue to rise, and we see a lot of conflicts on the world. And recently, globally we've been hit by the COVID-19. So a lot of these problems get accelerated, and we can see it pretty clearly. And well, MuSpace, we started very small. We've been in business for over 4 years now. And I remember the day when there was like only one desk, and starting with like really few people. And now we have 100 staff, and they're also joining us today. They're young, they're extremely talented, and hard works. And they can do big things and can deliver it on the big stage. So I think MuSpace, without all of you guys, we wouldn't, I think, be here today. So I think I would like a round of applause to you yourself. So everyone, yeah, please. Okay, thank you. For a history of MuSpace satellite program, so we started from the really small suborbital launches. If some of you may follow us in the past, we conducted 4 suborbital flights. So the goal back then was to master all this like small electronics, and also work with a core small group of engineers to master the technique. For the satellite program today, so there's a lot of benefits that we really pass on from that 4 launches and onto the real satellite development programs. And we started this program, I think, since last year, and the focus has been on the making it high powered from day one. When I said high powered, what I mean is, we would like the power per kilo, the best among peers, the best by far. So we embedded this philosophy to our team since day one, and so that was small teams, so teams of about 3 people, and now we just expanded to, as our team mentioned earlier, 100 of engineers. So yeah, so that's a little bit about MuSpace and how we get this far today. And today, the reason for this visual live is to announce the major milestones for the company. So I think everybody is excited, for sure. Yeah, so today we're gonna unveil our satellites that we've been working on, and I would like to welcome Phurit, our satellite production lead, to join me on stage to talk a little bit more about these satellite programs.
Thank you. Thank you,
Well,
James.
yep, Phurit, we've come pretty far, I think. Now it's the third factory. How do you feel?
Very excited, and right now it's very humid because it's raining in here in
Well,
Bangkok.
show us some excitement. When you get excited, how do you get excited?
I am calm when I'm excited.
Okay, you're calm and you're excited. Okay, all right. Phurit has been, I think, with us for a long time, and worked in this program from day one. And I think the day when we were just like 2 or 3 of us, and now your team is how big is your team now?
We have now about 20 people in our team working closely in the satellite program.
Okay, okay. And when I mentioned earlier, our team is really like young but extremely talented. I think the goal was to do something very difficult. You need a long-term like commitment, and so young generation fit perfectly. Can you tell me about your background, and then we'll just go on to the what everyone has been waiting for today.
Yes, so for those who don't know me, my name is Phurit Pookayaporn. I'm the satellite production lead at Space, and I have been working with James and also our teams, not just our teams, 20 people of the satellite, but also other engineering and other teams as well to build this project up from the ground. Specifically, we also have the power systems that build the cores of our technology, and also the advanced material and also the robotics that are working closely with us in order to gain the capability as well.
Okay. Yep. And today, Phurit mentioned that there's a lot of advanced material involved. So we will have our advanced material that will be, come and join us on stage
Yes.
at the later part of this presentation.
Yes.
So, well, shall we?
Yeah. So we are going to. So the reason we are here today is also to unveil this prototype, this Block 1 prototype new space satellite that we have been tirelessly working on. And I would like to welcome 2 of our teams to show us.
And music, if we can.
Okay, so this is the first prototype of the Block 1. Thank you, Brandon, and thank you, Nathan, for helping us. Yeah.
Right.
Right. James,
Yeah,
will
I'll
you
start.
tell about, yeah.
Well, here it is. We call it MU B200 Block 1. So that's the version that we intended to fly this thing in 2022. Well, we've been showing on the slide on the key performance. So there's a lot of, I think, the new philosophy that we put into this. New philosophy is said like the focus on the high performance, high powered, but we also put in a lot of innovation and deploy the latest technology. So maybe we'll go a little bit about this is the size. Obviously, it's about 0.8 meter, 0.9 and 0.3 wide in diameter. And the mass is about 200 kilo. So we built a 200 kilo standard onto this. I think masterpiece is because that's the I think it's in the optimal range. Because if you build it too big, then things really get really expensive.
Yes.
But we intended to actually have some kind of add-on to the platform, like the customers can actually pack more the power system, more batteries into our satellites.
Yes.
And this version that everybody is seeing here, it's the power generated by this battery that we assemble in-house. As also manufacture these battery cells is up to 1.2 kilowatts. So 1.2 kilowatts. So we just start from 1.2 kilowatts. But we have planned to really increase this, further
Yeah.
as we, putting in more into our research and development efforts that we've been focusing on day one. The other feature is on top here and connected to the main propellant tank. So this is the Krypton mini-sized tank. So this is to power the 600 watts thruster. So 600 watt thruster, it's actually quite powerful in terms of the size. So give you a sense of, a lot of people have been working on the size of about like 100 watts, 200 watts. So we've been like focusing on this 600 watts, and our intention is to crank it up to 1,000 watts. And also we have been thinking about innovation, and I think our engineer best on the left-hand side to work on these programs. And so we well, I'm just going to speak for you, but just to tell the audience that you work on, this is your program. So yeah, we plan to have an upgrade coming up, but block one will have this design right here. So this will generate about 1,100 seconds specific impulse. So the main mission is to do the deorbit and
also
maneuvering.
orbit maneuvering, yeah.
Okay, and yeah, for the design of the orbit and then design operational lifetime, I'll let Phurit back me up on this. Can you maybe tell our international audience a little bit more about this piece here?
Yeah, so as we look into the application itself, we found out that the power requirements of the future systems will be higher. And so that we build a more powerful systems, and also by having this the applications that deploy the systems on space in a longer time, we can also increase the length of the system lifetime. So we have found that for this size and for the particular design orbit, the first orbit that we are going to attempt is about 500 to 600 kilometers. We can have the operational lifetime of more than 5 years. 5 years is about the range that we are looking into. But in the future, if we increase the altitude, we can also increase the operational lifetime.
Right. So we intended to run it at really, I would say at high efficiency for over 5 years. We think what we design can actually, we'll talk a little bit like in details about the power system here. But we intended to make sure that, I think our system can last longer than 5 years. But it's because of technology is moving so fast, and then, our customers are scaling the network. So we in fact think that by that time, we actually have the newer breakthrough in terms of material technology, better batteries that we've developed and we've covered. So we packed this a lot of technologies in here. But just to tell the audience that I think we think 5 years is the right for what market is seeking today. But in terms of the robustness, the test, the standards that we go through in terms of testing, all these things has actually been going through like rigorous testing before we fly it, right?
Yes.
But what we show on stage here, this is just one model, right? Right now we build actually multiple.
Yes,
so
this is just a mock-up of our developing satellites.
Right.
We need to build more of these in order to not just get to know more and improve the quality of one satellite, but also enabling us to produce more than one.
Right. Yeah, we think right now for us, like doing one, I think we would be able to do it just fine. We just want the results to be repeatable. If we build like about 10 satellites, the Factory Zero, the first factory of MuSpace last year was really focused on the first concepts and then prototype that we've mastered. And the Factory One that we launched on our previous Visual Live was actually to build 10 satellites simultaneously. So this is like the work, the efforts that our team has been putting in. It's quite impressive. But for block one, we start from the 500 and 600 kilometers, but the future we intended to really serve wider markets by raising the orbits. But the designs need to be like reinforced and tweak a little to
Yes.
to fit those missions. So yeah, so so I just want to show everyone, proudly present this MU B200 Mu Space satellite bus
Yeah.
to all of you today.
So this prototype is also a particular milestone achievement for our teams as well. There are a very large numbers of people in our team working on all those components, not just the hardware itself, but the software that we put our tens of hundreds of hours into making this possible, and we are very sure that with more time and resources, we and our team can make this more robust, higher quality, and also in larger scale.
Okay. Yeah, so I think maybe you guys can come in and see how it deploy. So this is like when it's folded and then bolt into the launch vehicle.
Yes.
So it would be like, this is like the top of the rockets.
Yeah.
And then on that booster on that side, and then we also built the separated by ourselves, right? So this is like under the design and manufacturing and testing phase, right?
Yes.
Maybe you tell our audience a little bit more about like what we built. Usually, people don't build entire systems, but we do. So we call ourselves like vertically integrated, meaning that we do everything end to end. So this actually, we build this entire system by ourselves and included an extra, which is a separator. I think the interface that connect to the launch the rockets, like
Yes.
So this I think this interface is very standard. It could actually bolt into the Falcon 9 systems, Blue Origin, Relativity, all this like launch providers. It's like so yeah. Tell audience a little bit more about the system.
Yeah, so right now it's in the stowed configuration, meaning that when we actually put this onto a launch vehicle, it's going to stay in this configuration, in this pose. But when the launch vehicle actually deploy these satellites in the space, we need to expand the solar panels that we have shown here. So this is the mock-up that we have placed about 3 panels on, but for the flight systems, it's gonna contain a large numbers of panels and also on both sides. Here we also just to show you the mechanisms of the deployment. On the Nadia side, the side that is facing Earth, right here, it's going to contain all the antenna and communication system to enable the satellite to speak with the ground stations. Yeah, and in order to maximize the power, the solar panels has to be optimally adjust to the sun angles. So the solar panels also equipped with the solar drive mechanisms, and that also included in the power system, the power electronics that track the maximum point for the solar panels to operate.
Right. And to note that's will be even on block 1 and the iterations, we intended to improve the structure like dramatically. So there's a lot of reinforcement that we try to really make sure that as we go forward, we want to like the center of gravity. I think center and low.
Yes.
So we this version is still we work on. I think we have what our customers will see will be slightly adjusted, but in terms of key components like powering the satellites, it's the same.
Yes.
But then in terms of the alignment, we intended to do better. We've been investing more of the high precision toolings. So all these things that we intended to put it in the right as we get more data, then we could optimize this further. And this is the structures. We use the aluminum alloy, but we like the key. Fundamental, the alloy is light, the aluminum is light, but we found that, but we mastered the technique to work with the aluminum. But we think aluminum is actually, if we need to build a lot of these things with aluminum, we think it's actually will increase the cost. We intended to optimize it with the steel alloy and some of the composites and polymer and some of the techniques that we could craft some of the existing structure out to make it actually stronger and lighter weight. Yeah. So anything that Phurit that you want to add that I've been missing out?
Yeah, so particularly these satellites are built in the design philosophy of modular. You might see modularity in satellites design in latest upcoming years, but the satellites that we are building now has a higher capacity. So by incorporating the modularity to the satellites, you can essentially increase the power or adjust the power to the payload that you want to input in. So we have 5 sections in particular. The first one is the power system, the heart of it, the heart of the satellites. And then down here we also have the attitude control systems, the system that control the orientation of the satellites. And the third section here is the electronic sections that houses the onboard computers and other avionics aboard the satellites.
Right.
Then the sections here, as mentioned, there are the thrusters sections that houses the fuel tanks and then the thruster chamber.
Right. The other program that MuSpace has been working on is on the altitude control. It has the powerful small motor, brushless DC motor. We've actually been working on this in Factory Zero.
Yes.
And we build our own, the small electric motors, and to get, I think, higher torque and higher RPM, like better efficiency. Try to actually, we found that the motors that we build in-house actually outperform, all the, because beginning when we test these things on the altitude control, we source it out to a supplier, and then we actually see that we want higher precision, because higher precision turns into higher performance. And then we, from the first chart, we talk about the performance focus. So we ended up, decided, I think early on this year that we're gonna do, the electric motor ourselves, and we did just that.
Yeah.
Yeah. So anything else that you want to show the viewers here, like antenna, maybe?
Yeah.
It's very
So
important.
the antenna is on the outer
Yeah.
sides.
So
Right now
we
we
should-
are
yeah.
working with the dielectric materials, but we also see that having the dielectric is suitable for telemetry and other lower frequencies applications. But in higher frequencies, the dielectric antenna becomes too large, and we see that to change from the technique of the dielectric to other technique like the cavity slotted antennas. That
Right.
increases the capacity, the efficiency of the antenna itself, and then increase the capacity and the capability of the communication system that improve the data rates that the satellites can service to users.
Right. Yeah, this one is dielectric. Yeah, Phurit's team and I has been working on the other technique called cavity slotted, and this is to make the antenna simpler to manufacture.
Yes.
The key to antenna, well, just to explain a little bit, the key to antenna is the high gain threshold, right?
Yes.
And so we want to, maybe the people, I think globally is familiar with about like 30 dBi, but we try to crank this up to about 40. So there's this like techniques also solid state to make this higher, higher. We're targeting like over 40,
Yes.
and also make it simpler, because dielectric, like if you look inside the way we don't have it here today, but it's pretty complex. It just make like to build, let's say like 10 to 100 satellites. I think dielectric it's totally fine, but if you work with like the constellation, like serving internet for people around the world, 10 million users, then it's very difficult. So it's not scalable. So we switch it to cavity slotted, and it's become like looking like this, but it's stack it out, just keep stacking, like if the customers want I think more bits, then we would pack in more antenna. So what is capped? It's actually this antenna and also the power system. So we tell you about 1.2 kilowatts, but then we want to crank it out even more because we think that you want high power, you want your internet speed to be extremely high, large pipe. So yeah, so we think that was the reason why we said this block is 1.2 kilowatt, like 1200 watts, but then as we improve the battery ourselves, battery cells, can actually pack about 2.5. So you could actually, well, I said the number, it's about 2.5. If we're able to deliver on this like battery production, then we would be able to crank it out about 2.5 times what we show you today.
Yes.
Okay, so I think.
Yes. So thanking our
Okay.
team for having
Well,
us.
just leave it here, and thanks you guys. Okay, let's throw it to the audience. All right. Okay.
Thank you.
So we keep saying like our satellite is high powered, high powered, and high powered. So this chart is showing our viewers that the peer comparison. So this is like comparing with the leading peers today. So I think by the shape, everybody knows who they are. So the A, it's the architecture used by one of the satellite internet constellations. So it's operating about 200 watts. B is operating about 700 watts, and there are about like 1,000 of these things on orbit today. So for our systems is on the left-hand side. I think I'll have to go over to Phurit. It's 1,200 watts. So this is just to give you the system that we are developing is about double, more than double what is been using on market today. And I mentioned that we intended to increase the capacity of the battery, the energy density of the battery, which we will talk in a minute. So we could, in theory, crank this up to 2.5 times that number. So this just to give everyone of where we are and what kind of technologies that we work with to enable this such a high performance. Okay, so that's pretty clear on the overview of our satellites. We'll go into the competitive advantage. Okay, so we'll first start with the reliable. Now it's not high powered, reliable power systems. Being high power is not the only thing. There's other factors. We find out that these systems we need to work with really high voltage applications. So we need to build the power system that is reliable with the high voltage applications, and also the protection is very important. If we need to be able to protect it whatever is inside. So the short circuits, and we have to be super reliable because this thing one is launched, and if there's malfunction and that's contributed from this high voltage application, then the entire satellite could go down. So I think Phurit mentioned about the team works on electronics and software. We have quite a big electronics and software team as well, and then we work alongside the hardware from day one. So this is to build the very strong protection systems, and also we call it battery BMS, battery management systems. So these systems actually need to really control how this battery packs intended to feed the power to other components of this satellites. Yeah, Phurit, do you have anything to back me up on the reliable power systems?
Yeah, so as I mentioned earlier, the power system here is designed not to match the power capability that we say. We say that 1.2 kilowatts, but the power that we actually packed in is higher than that, because we see that the redundancy of the power system is very important. Battery cells, in particular, are sometimes prone to errors, and they can mismatch the voltage. And by having the redundancies, we can switch back and forth between cells and having the power system in full operation at all time. And as James mentioned, the battery management systems here actually mitigate and manage that kind of cells problems that will happen when it is launched into space, and manage that to incorporate the power that will be more reliable based on each cell's capacity, and feed that into all electronics that sit inside the satellite.
Right. Yep. So that's about the power systems. Well, next up, we said customized for specific market. In fact, we made announcements on our international partners, like the world leading aerospace manufacturer that we work with, like since last year. So we've been like tailored this, for working really closely on the technical level and also commercial level. So we're getting good at this, and something that customers are always like demanding, and we understand that, and usually we need to build something that the life cycle is actually longer than it should be, is because there's certain qualified lifetime standard that our customers is actually required. So basically this thing actually going through all that, like test to meet that standard.
Right.
So all this thing is like we tailoring for our customers for our first few satellites, and one is scale up. Then we would find a way to simplify the manufacturing process and deploy the vertical integration, to make sure that the customers would have this, apart from just being a high performance, they could actually enjoy the cost benefit, as this project begin to take off.
Yes.
Anything that you want to back me up here?
Yeah, on the qualified lifetime, so not just the ground test that we are going through all these components, but also we plan to have a test flight in order to qualify this in actual space environment. And after that, we can simplify the design, improving that, and also customize the design to a specific applications, like communication and also remote sensing applications that customers all around the globe are looking for in satellite systems. And by customizing that, we can then simplify the design and making more of that for our customers. And as James said, it would drive the cost down significantly.
Yep. And just to bring this forth, we work with one of the constellation operator, like the LEO satellites internet constellation. We found that being high power is not the only thing. The other part is the coverage. Our customer want to make sure that they have something that would have coverage. So we need to be in between. So we built this thing high powered, but as we engage with them, they're kind of like, okay, now you could do high powered, and you far exceed that, and they coming up with the requirement that maybe we could build something that could maybe provide a better coverage. So which we mentioned from the antenna on the back side. So those are really for we could actually tweak it a little bit to serve that need in terms of coverage if it needs to be. Yeah. Okay. So MuSpace vertical integration focus. So meaning that we take the raw material, machines is in-house, firing hot in factory 0, factory 1, and we'll be on factory 2 where we're standing. and then process to the deliverables, like products that can be delivered. So all this process takes from the design, fabrication, testing, and qualification. Then we think we try to cap it at about 12 months. So the industry today is about like 3 years. So we add about like 2 or 3 times like better than the industry pace at this point in time. So what we intended to do here was to really use the vertical integration, everything built in one place. And if there's any technology like that we would like to insert, so we would do it and tell our customers that they will be available in the next 12 months. So for the customers that work with us like long term, they do get the products that keep getting better. Like we need the early ones that there will be some glitches and some faults, but something that would not like destroy the systems. So because we're running through all those tests to make sure this is robust, but we expect that there will be some improvement still that we can do. So meaning that if let's say you order next year, and then it takes us about 12 months, which is next year is 2022, and you ordered, and 2023 it comes out, it's likely that the performance will be higher when you make your decision. So this is the key on why it has to be vertical integration and why MuSpace is different. Because a lot of people asking me why and why, because we build everything in house, and we the only vertically integrated in Southeast Asia at this point in time.
Yeah, and the benefits of vertical integration is that it not solely have our engineers, our technicians, see the problem firsthand early. That enables everyone, our team, in order to build a great system, to see the actual problems that would occur in the first day, and that building up the knowledge and know-how how to do, in particular, any parts of the satellites. And with changing technology, our teams can leverage the existing knowledge and know-how in order to build the new system faster and scale back and scale up to higher volumes in order to serve our users, our customers.
Okay. So the focus was to passing on the value from the latest technology onto our customers.
Yes.
As soon as it's available. Yep. So we have a video on what vertical integration means. So I'll just run through the video. All right, so that's like 1 minute of packing like maybe tens of thousands of hours into just one minute. Yeah. It's quite amazing. So thinking about when there's only, I think, very small team, like 4 or 5 of us. Vertical integration. So the key is because being vertically integrated allow you to build almost everything in house. So there's actually a components level. This is a system level. This is entire system that we intended to sell entirely, but also there's a component level. So the power system, the component level. the altitude control is component level. The ion cluster is component level. And so that just for example. So we do make this from orders. This is like the side benefit from being vertically integrated. So this is also the product line that there is some aerospace manufacturer that might be interested on particular component. Then we can also do that. So I'll deep dive onto all this component for all the audience online to see it.
Yeah, so the first part is the space-grade battery. So conventionally, we would use conventional lithium-ion batteries, and so we have also our teams, our power system teams have here, leading by Chachanan.
Yeah.
He will introduce us into the next step, next generation of solid-state lithium-ion batteries, please.
Okay. Thank you, Phurit, for introducing me. Okay, first of all, let me introduce myself. I'm Chachanan, and I'm the leading of the power system development project. And with me today is people who working on the battery development project. First is Mr. Neti, second Mr. Apishai, and third is Ms. Parishat. Okay, and today.
How big is your team? For
right now is about 11 people in my team.
Yep. So 11 and scaling.
Yes, and scaling to developing more and more the amazing things.
Okay, and the backgrounds, our guys' backgrounds, Shashanan's background is in nanotechnology.
Yes.
And maybe just tell a little more about the backgrounds of your team.
Okay. Neti, can you introduce about yourself a little bit?
Okay, I work about the energy storage, and I learned the primer for the
your background.
Yes.
Your background.
For develop the battery. Yes.
Okay, polymer. Okay.
Nano material and advanced material.
What's that?
Sustainable energy and resource.
Okay. So background is in energy.
Yes.
And like material.
Most of them is material and about energy storage and nanomaterial.
Okay. So you ready to talk about like what's inside?
Yes.
Nano level.
Yeah. Okay.
All right.
Most.
We're gonna go close to the battery.
Okay. Okay. This is the battery pack that we have integrated into the satellite. We mainly focus on the high power that, as Phurit mentioned. Okay. And right now we have developed the future battery that integrate and implement our own cell design. As I have may inform you guys before, we are developing the solid-state battery that have higher performance if compared to the conventional battery.
Okay. Yeah, the conventional battery, we see this high, I think the content of the nickel need to be high. The nickel.
Yeah.
We want our battery is higher nickel content. And also we would like to switch out carbon with nano silicon.
Yes.
Silicon powdered nano size, like 1 nanometer, like very, very small in size. So that's actually, tell a little bit about like what you've been working on. I think we've been invested heavily on the battery side, and we have in factory one. So just tell the audience like what kind of machines and tools that under your team, that you use to build this like battery cells.
Okay, in a factory one, we have a laboratory to do a research about the solid-state battery, and in the laboratory there are about 30 machines that working to produce the battery cells.
Okay.
And today I have bring the sample at our
bring it on.
prototype.
Bring it on.
Yeah.
Right.
Yeah.
Small. Okay.
Yeah. This one is a prototype of solid-state battery that this is in a coil cell shape, and another one that is the solid-state battery in the cylindrical cell shape.
Okay. Yep. So I'll just hold it for just one. So the camera Yeah, so this is the size of, I think you start off with, I'll just hold for you and you can talk. So this is what?
Yeah, we have start with this one because this one is the small size and we easier to pack into the cells. But this one is more complex because we have to at first we have to fabricate into the flat sheet and then we have to roll them and pack them into the cylindrical cells.
Okay, so meaning that for this, like the size of the buttons, this is to test the battery property?
Yes, yes.
Okay, like and this is like the one that we fit into the satellite.
This
right?
battery
And this is actually we do this from inside of our factory one.
Yes.
Battery lab, right?
Yeah.
Okay. All right. Cool.
And
Anything else you want to add for the online viewer?
Yeah, I will tell you guys a little bit about the battery cell design that we have designed about the anode, cathode, and separator. Okay, I will pass to the Mr. Neti to talk a little bit about our own cell design.
Okay. Yeah, I think that was, I was just want to be clear, I think, because we were wearing masks here. The inside, there's not just, I mentioned nickel and silicon, but there's some others as well. So Neti would like to tell what's inside the battery.
Yes.
Please.
The first in the cathode, we synthesize about the NMC or nickel manganese cobalt. Is the composite on the cathode side. And next in the anode side is use the silicon graphite carbon. Yeah, and it is the highlight of this battery is the solid state electrolyte. It's used the polymer mixed with the ceramic. Yeah.
Right. Right. Yeah. So we keep saying solid state, but that's actually a formula that we come up with. So there's a number of like chemicals that we need to work with to perfect this technology. So as I mentioned that right now from the existing is about 1,200 watts, and then we want to, once we master this, and then this goes into production next year, we could actually continue to step up. I think you guys are working hard on that. Right. Okay. All right. Well, thanks, guys.
Thank you very much. Thank you. I can tell there are no liquids inside.
All right. Yeah. So we solar panel.
Yeah.
is next
so,
one. I just want to say it before Phurit. We work on the battery, like myself, Phurit, and Chachanan, work closely on the battery programs. So Chachanan is the third guy that was on the early days small engineering team. And then we found out that that's an improvement that we could do for the solar panel as well. I'll let Phurit tell the viewers a little bit about the solar panel program.
Yeah, so the battery cells are just the energy storage compartment, but actually the system, the part that will eventually generates the power once the satellites are in orbit are the solar cells. So we have here just the solar panels, but the solar cells will be mounted on these panels. But the reason we not bring it out here because it's quite expensive, and that's exactly what we see the problems in having a large scales of systems deployed in space. It's expensive, and also conventional solar cells are not very efficient. The current solar cells technology that are deployed is multi-junction, but the downside of that is it's very expensive. It's very hard, difficult to scale up the production, and that disable the scalability of the satellites. So we see that the materials and also the manufacturing process, in order to make that multi-junction cells cheaper and also lighter, in order to have the high powerful satellite system deployed in a scalable way.
Right. I think by next year we've been investing on the all this advanced manufacturing techniques, and lately we've done the optical as well, optical lab. I think it's to I think we found a way. We've already found a way to make this more, I think, cost effective and maintain the performance level. That's two things to it. I could talk a little bit about this. The materials. So the reason I said, well, we put this like right after the battery because it's in the material that certain material that is very costly. So we want to really find a technique that's we'll be able to swap it out, but then maintain like the efficiency level. And the second is the manufacturing technique as well. Right now, this panel are multi-junction, so I want to make sure that we could maybe do it with a couple of junctions.
Yeah.
Still multi, but in dual. Decrease that junctions. Then doing that, let's say we could drive cost by half, then that can actually pass on the cost benefit to customers. Antenna, we talk about antenna, but anything else that you want to cover further on antennas?
Yeah, so the antenna of the satellites, as I mentioned, and as you know, we have been engaging in the development of the cavity slot. So it's a phased array antenna, and not just the gain and the manufacturability of the antenna itself, but also the flexibility of the antenna. By having a phased array, you can adjust the beams to a specific locations on the Earth in order to increase the flexibility of the system. Meaning that you can focus your beams, your communication side onto specific areas and increase the capacity. Basically, your internet should be higher when you have flexibility in your antenna, because the satellite is once it deploy on space, it can't really move that much, and by having a flexible antenna, you can move your system around, kind of like on Earth.
Right. The altitude control, this is a test bed. I think this you saw it on the video, but this is when we actually test the alignment and precision of our. Right now, it's moved to our factory 1, and then we've also approved to actually scale up the test facilities by maybe about 5 to 6 times, coming up, hopefully by the end of the year, and focusing on better alignment, better performance, higher torque motor. A little bit more about this guy right here.
Yeah, in particular, so our team has been effortlessly make these components. So this is actually the second revision, and we see some issues in the second revision, and we will improve upon that as well. And particularly in 2 areas, the precision, the alignment of the systems, and then the stability of the system, because the attitude control is basically the system that would align and orient the satellite in a specific orientation. And having a very stable pointing, you can actually have a very more powerful and more stable equipment upon your satellites, like the remote sensing and other communication technology. And by improving that capability of the attitude, you can have more payloads capability and serve more customers.
Right. Okay. The other one that it's inside, it's the chip that we use. We think we working on the designs that we are designing our own chip. But this show here, we need to source a chip out from someone else. But then the reason that we need to we've already kicked off the design of the chip programs, but our own chip will be available in the end of 2023, I think the earliest. So I think that would be in about block 3,
Yeah.
block 2, block 3. But that's coming up, so we will try to get all this design effort done, and then design takes about 6 months time. And I'm sure if that's a request from our audience, you could send it to our team, and then we'll if you want to know more, we'll get our chip, the data computing team to deep to the chips that we've been working on. So the chip on I think is the size of your smartphones. If everybody use the iPhones, it's about 5 nanometer right now, and then but we saw that's 2 nanometer, that is becoming available on the lab scale. So I think that would be the size that we'll be working with, like between 2 to 5 nanometers for our own chip in 2023.
Right.
And this one is also another chip, but it's atomic clock. This one is super important. This is actually in-house. This is like we have this, but we got the chip for the CCM atomic clock. You know, it stands for chip scale atomic clock. It's another chip, but this chip is for the GPS, right? The advanced GPS. Now you cannot live without GPS. So this one, the current GPS is on the MEO, about 8,000 kilometers away from you. But the LEO systems that we are building for our customers, they really intended to, you know, like deliver the advanced GPS. So meaning advanced GPS meaning that you will be able to pinpoint the location like very accurately and also use less power because now the satellite is closer to your smartphones or closer to your autonomous vehicle, let's say, then that makes a lot of this, you know, become like super accurate. So this is very exciting technology that we have now in-house, and we intended to improve this further. And not to mention another application is the advanced GPS is very important to blockchain, you know, to cryptocurrency. So I think it's very hot topics, right? I've seen like many docs online, right? So it's very hot. So it's directly related to the crypto. So if you are a crypto owners, I think what we are working on is infrastructure for that blockchain, for that the next generation network. So it's directly related to that. But we need to focus on this first, and then you know, like the blockchain ecosystem will benefit from this as well. Anything on the atomic clock until we move on?
So right now we saw science sits the chip scale atomic clock is actually sit in our factories, and we will incorporate that into the telemetry of the satellites, and by broadcasting the local time of the satellites, and having that on the orbit, we can enable, you know, blockchain technology and other applications at a larger scale and at a more higher quality to our customers.
Right. Okay. And this is very important one. The ion clustered. So this is very important technology that we've been working on.
Right.
And this is like super important for the future of new space. Like from the first chart, we mentioned about the 600 watts ion clustered. So this is how it looked like, you know, but because space is dark. So what it looks like is like a light blue glow that actually, you know, push the satellites. So the first generation, we intended to put this is actually right here. So this is like, if you look on top, the light is glowing from this angle up, but then on the screen it's on that side, but the actual one is on this side.
Yeah, it's from this chamber.
Yeah. So block one gets standard ion cluster like 600 watts, and we are now coming up with dual tank systems. Right now it's a single tank, but for I think block 2 will be like dual tank. So the main application is to really to maneuver, you know, if you want to change or reposition the location of the satellites, then you could use this thing. Or you, let's say like end of the life, then the way we you know, one is end of life. All these things are designed to burn up in the atmosphere. So we would use the ion cluster to, well, at this angle to push it down. So that would like completely burn up in the when it's entering back in the atmosphere. The other that we intended to do on, I think, block 2, we'll get it, and that's the reason why we want to use the dual tank. So the other was to really to you can bring it down, and you can also,
Bring it up as well.
you also like can push it up as well. So I mentioned this because the next chart is actually our test flight timeline. So it's separate by the altitude, and I'll let Phurit is in charge of all this like schedule. So I'll let you talk a little bit about what's coming up in terms of our test flights activity.
Yeah, I would say that it's not only the engineering team that has been working towards test flights. All of our team have been working tirelessly for making this possible. And when customer sees our products, one of the things that we have to make sure before we actually pass these components to our customers is that it is very reliable and it is proven. So we plan to have the satellite system proved in the space environment. And for the first particular this particular block of satellites, the first block, we plan to test it next year and qualify that in Thailand and then send into space. And this block is particularly designed for a low Earth orbit, particularly in 500 to 600 kilometers. And we want to increase the altitude in order to versatile our capability for a more wider ranges of applications for our customers. So the altitude will be increases from 500 to about 1,000. And then upon that, not just LEO applications, but also the medium Earth orbit and also the geostationary Earth orbit is also a very good resource to utilize. That space will enable a wide range of applications like communication, navigation, and remote sensing. And we plan the test flights on, as you can see here, from this day. Next year, we would like to test this block of satellite, and then we have years and years after that, we will test the next block, and we'll offer these satellites to our customers.
Right. Well, we've the block is separate by the constellation. The block one is to serve the low LEO, low Earth orbit. So it's between 500 to 600. So that's where we start. Block 2, it's on the high of the low Earth orbit. So 1,000 to 2,000. And the block 3, we go a little bit high, a lot higher to MEO and GEO, where a lot of existing technologies, a lot of incumbents, a lot of existing networks, like the old technologies on there, that needs to be refreshed. But then those block 3, I think I mentioned about chip. They have to be some kind of radiation hardening process that needs to happen. That chip that we show you that we have in house today only function on block 1 and block 2.
Yes.
So our own design chip that would have the intention to serve the higher, the location where this hardware exposed to radiation. So we want our system to perform correctly. So you need to hardening that chip. And block 4 is really interesting. We said it's like beyond 35,000. Those are like deep space. so I think we saw a lot of visions, I would say, and visions and missions from like space agencies around the world, like around the world, like Asia, United States, like Australia, Europe. That's an increasing numbers of cislunar missions. Like these are the deep space mission. Like going to the moon is a deep space mission. Like beyond the moon is even deeper space mission. So we that for block 4 to build this for this like deep space missions.
Yes.
But that's like 2025. Okay. Well, I'm gonna go into the production scalability. So thanks, Phurit, for going through this with me.
Thank you. So I hope we can scale this up from 1 to 10 as well.
Okay.
Thank you.
All right. Thanks, Phurit. So everyone, Phurit. Okay, so the last topic, it's very important is the production scalability. I'll just go on that side. Yeah, so the production scalability is very important. You know, like to build one prototype. I think that's not important because that's not what customers are buying. So they yeah, but we need to start somewhere. So we start with one. So this is, you know, the one. This is the first factory that we start last year in Factory Zero. You know, the first one is to actually to get the fundamental concepts right. So you want to get the right power systems, you know, the right structures, the right altitude control. So you want to get it right from the first one. So we got it right, and so once we got it right, we made a decision to do it like, oh, okay, now let's do like 10 of these things, and make sure they are repeatable, and so that's where we are today, New Space. So we built 10. We have ability with like 100 staffs. We could do 10 at the same time. So I just want to tell our viewers that we could now do 10 at the same time in Factory 1 that is now online. So the 10 still, you know, as we have this 10, we basically deploy the vertical integration fully. So that's, you know, like when you be on one, you know, we didn't have a specific, let's say, machines back then. You know, we need to really, you know, get it out to suppliers, and so we've been seeing this complex supply chains in Southeast Asia. So it was very difficult for us like last year. So we solved that, and then we bring this like machines in house, and then we shorter this manufacturing process, you know, to do everything in house, and can do it in initial volume. And so the last one, it's like we want to do 100 of them. So and you know, we tell you that our customers are building the satellite internet constellation, and there will be about 10,000 of these satellites. So we want to be able to deliver it on the first 100 for them. So the intention is actually, you know, we need this factory that we are, you know, include on this Unveil on a Factory 2, just to serve that, you know, if we get 100 satellites order this kind of volume, New Space, we will be able to, we actually will fund it to serve that type of volume. And the next slide is just to help you actually mapping what we've done. So the Factory 0, Factory 1, and Factory 2. 1 satellite, 10 satellites, 100 satellites. So that's where we are today. We could do hundreds of satellites. We could do these satellites, you know, have tens of thousands battery cells. We could do that. These satellites have tens of thousands microelectronics. We could do that. So yep. So that's actually wrapping up. And so New Space Factory 2, where everybody is here. You know, our team, and also our fans, our partners, our supporters online. Who likes and shares and talk about us. So today, you know, we actually visually tour you with our teams on the Factory 2. So this factory will ready to start operate in the end of October. So very exciting and very nice facility. So yeah, can't wait to really like host some of you. Well, most of you, and then we would like to host you once we prove to host you, and when the COVID situation gets better. Well, yeah. With that, I would like to say thank you for your support, and for more information, you could go into our website, www.newspacecorp.com, and then, you know, for any inquiries related to business, technology, partnerships, like investments, you know, you go to our websites, and our website is actually I would say super cool too. It's very easy to navigate. So please use them for the best of your benefits. Well, I would say it's now almost getting dark. So good night.
Thank you, Kun James and Kun Phurit for the presentation. Now we are all understand about the satellite technologies, about the manufacturing, and also our new factory as well. Let's move on to the next question. Next session will be the Q&A part, and we will talk more about the satellite business. Let's have a seat.
ค่ะสำหรับช่วงนี้นะคะก็จะเข้าสู่ช่วง Q&A session นะคะก็ขอเชิญคุณเจมส์แล้วก็คุณภูริตนั่งได้เลยค่ะก็สำหรับช่วงนี้นะคะก็คือเราได้รวบรวมคำถามต่างๆจากแฟนๆนะคะแล้วก็ผู้ที่ติดตาม Mil Space มาตลอดนะคะแล้วก็วันนี้เราจะมาตอบหลายข้อสงสัยให้ทราบเกี่ยวกับ Mil Space ค่ะเดี๋ยวเริ่มที่คำถามแรกจากคุณกรินเลยค่ะ
ครับอย่างที่เราทราบกันแล้วนะครับว่า Mil Space เนี่ยเราให้ความสำคัญกับคำว่า vertical integration มากๆเลยอยากจะให้ทางคุณเจมส์เนี่ยอธิบายถึงข้อดีหรือว่าข้อได้เปรียบของการที่เราพัฒนาเทคโนโลยีด้วยทีมเราเองแบบ vertical integration ครับ
ครับก็ vertical integration ที่แป๊บนึงนะ vertical integration ก็ที่ได้บอกไปก็คือว่าเราพยายามที่จะทำทุกสิ่งทุกอย่าง in house ก็คือว่าทำทุกอย่างตั้งแต่ต้นจนจบเลยก็คือว่ามีเป็น raw material เข้ามาในโรงงานเรานะครับมีเครื่องจักรที่ชนิดที่เราดีไซน์และสั่งพิเศษนะครับแล้วก็มีเครื่องเขาเรียกว่าทดสอบต่างๆเนี่ยอยู่ข้างในบริษัททั้งหมดนะครับอันนี้คือพยายามทำให้ได้มากที่สุดครับก็ได้ประมาณ80% 90% นะครับก็อันนี้เป็นสิ่งที่ Mil Space เนี่ยทำแล้วก็มาเป็น final product ตรงนี้มันคือว่าถ้ามีอะไรมีปัญหาเนี่ยเราสามารถเรียกได้ว่าตอบลูกค้าได้หมดนะครับแล้วที่สำคัญที่เมื่อกี้ก็พรีเซนต์ไปนะครับในเซสชันเมื่อกี้คือว่าเราสามารถใส่เทคโนโลยีใหม่เข้าไปเนี่ยได้ทุกๆปีนะครับเพราะว่าหลายสิ่งของเราเนี่ยมันจะเป็นลักษณะเหมือนกับเราได้ออเดอร์มาก่อนนะครับเราใช้เวลาประมาณ12 เดือนเนี่ยในการที่จะใส่เข้าไปอันนี้เราเลยเป็นสิ่งที่ว่าเราต้องการจะใส่เทคโนโลยีใหม่ล่าสุดเนี่ยให้กับทางลูกค้าเราเนี่ยได้ใช้เร็วที่สุดนะครับอันนี้ก็เป็นข้อดีของทาง vertical integration ครับถือว่าถ้าต้องมีซัพพลายเออร์เรื่อง raw material หรือว่าบางสิ่งบางอย่างที่ซัพพลายเออร์ที่แบบมี special ability ก็จะเป็นคนที่เหมาะสมกับ Mil Space มากนะครับเราก็อยากจะเห็นทางซัพพลายเออร์ทางเนี้ยให้เขาเข้าใจคอนเซ็ปต์ vertical integration เนี่ยก็เวิร์กควบคู่กันแต่ก็ต้องมีว่าเรามองว่าบริษัทที่มีการลงทุน R&D ลงทุนในคนนะครับลงทุนใน engineers builders technicians ต่างๆที่จะสร้างระบบขึ้นมาเองอันนี้เป็นคนที่เหมาะสมกับทาง Mil Space มากเป็นคนที่ค่อนข้างจะลงทุน R&D ต่อเนื่องนะครับแต่ว่า Mil Space เราลง R&D ค่อนข้างเยอะนะครับก็อันนี้เป็นสิ่งที่ตอบกินยาวหน่อยแต่ว่าก็ตื่นเต้นกับสิ่งที่เรามาถึงวันนี้ได้ครับ
ครับน่าสนใจมากๆเลยครับทีนี้อยากจะถามทางคุณเอิญด้วยว่าสำหรับการรูปแบบการทำงานแบบ vertical integration เนี่ยมีผลยังไงกับการทำงานหรือว่ากับทีมบ้างครับ
ครับก็ vertical integration ก็อย่างที่ทราบนะครับว่าเรา engage กับทุกๆ part ทุกๆชิ้นส่วนในดาวเทียมเนี่ยตั้งแต่วันแรกทุกๆทีมที่เราสร้างขึ้นมาก็จะมีหลาย component ที่เรา engage มากซึ่งอันนี้ก็จะทำให้ความสามารถของทีมเนี่ยมันค่อนข้างจะหลากหลายมีความหลากหลายทั้งในเชิงวิศวกรรมทั้งในเชิงของการจัดการงานต่างๆที่เข้ามาครับเนเจอร์ธรรมชาติของแต่ละระบบแต่ละชิ้นส่วนมันก็จะไม่เหมือนกันซึ่งทำให้เรื่องได้เหตุผลนี้มันทำให้ทีมหลายๆคนนี้ได้มองมุมมองที่ต่างออกไปแล้วมันทำให้การอินโนเวทการคิดสิ่งใหม่ๆคิดโซลูชันที่มันตอบโจทย์กับระบบที่เรา develop ระบบที่แต่ละคน develop เนี่ยมันมีมุมมองที่หลากหลายมากขึ้นครับผม
โอเคค่ะก็คำถามต่อไปนะคะก็ถามคุณเจมส์ค่ะว่าหลังจากที่เราเนี่ยเปิดโรงงานเป็นแห่งที่3ของ Mil Space แล้วเนี่ยก็คือโรงงานแห่งนี้ที่เรานั่งอยู่นะคะชื่อว่า Factory 2อยากทราบค่ะว่าจุดประสงค์หลักของการใช้งานภายในโรงงานแห่งนี้คืออะไรคะ
ครับก็โรงงาน Factory 2นะครับจุดหลักเนี่ยเป็นเรื่องของตัวตอนนี้เราจะเห็นว่าเราคุยเรื่องแบตเตอรี่เนี่ยเยอะมากนะครับเราแบตเตอรี่เนี่ยในโรงงาน Factory 1เนี่ยมันเป็น lab scale สเกลเนี่ยเราก็จะผลิตประมาณสัก100ยูนิตประมาณ100เซลล์เพื่อที่จะแบบพัฒนาควบคู่กันไปFactory 2เนี่ย intention คือโฟกัสในการสเกลตัวแบตเตอรี่เซลล์นั่นเลยนะครับก็คือว่าสร้างจำนวนเซลล์เนี่ยได้มากขึ้นนะครับจากตัวจำนวน output ทั้งหมดเราคิดว่าเราน่าจะทำได้ประมาณเต็มที่ประมาณ100,000 เซลล์ต่อปีนะครับ100,000 เซลล์ดูตัวเลขมันเยอะแต่จริงๆก็ไม่ได้เยอะถ้าเป็นก็ยังเป็นอยู่ในเป็นลักษณะเป็น low volume size อยู่นะครับเป็นอันที่เราโฟกัสอีกอันนึงเนี่ยก็คือเมื่อกี้ผมคุยว่าหลายๆส่วนเนี่ยมันมีเรื่องอิเล็กทรอนิกส์ด้วยเราก็ intend ที่จะ scale our electronics program ก็คือว่าเราเห็นว่าเรา master พวกอิเล็กทรอนิกส์พวกนี้อันนี้ผมพูดถึงตัว microcontroller ตัวชิปตัวเล็กๆต่างๆเนี่ยเราก็มีแผนที่จะลงทุนในตัวเครื่องที่แบบในการวาดลวดลายเลยแล้วก็ทำในตัวพวกแผงวงจรพวกนี้หรือว่าพวก microcontroller เนี่ย in house ก็แบตเตอรี่กับอิเล็กทรอนิกส์เนี่ยก็จะเรียกว่าเป็นจุดโฟกัสของตัว Factory 2 นี้ครับ
โอเคค่ะแล้วมีแผนต่อไปในอนาคตอย่างไรเกี่ยวกับการสร้างโรงงานบ้างอะค่ะ
ครับเราก็มีแผนโรงงานที่จะสเกลมากกว่านี้เนี่ยประมาณ10 เท่านะครับอย่างที่บอกว่าเราอยู่ในช่วงที่เป็น low volume นะครับแบตเตอรี่เซลล์100,000 เซลล์ต่อปีนะครับดาวเทียมประมาณ100 ดวงนะครับก็เราอยากจะสเกลขึ้นอีกประมาณ10 เท่าตัวนะครับตอนนี้ work area Mil Space ทั้งหมดเนี่ยในโรงงานประมาณ 5,000 ตารางเมตรนะครับก็อันนี้เป็น area ที่แบบเขาเรียกว่าเป็นพวกที่ทำเป็น clean room ได้ทำเป็นเขาเรียกว่า high grade ก็คือเป็นโรงงานผลิตที่มีประสิทธิภาพสูงนะครับแต่เราต้องการจะจริงๆเราได้ cover ใน Visual Life ก่อนด้วยว่าเรามองหาที่เพิ่มเหมือนกันก็คือว่าที่ใหญ่ขึ้นกับ Factory 2เนี่ยประมาณสัก10 เท่านะครับอันนี้ก็เป็นสิ่งที่ว่าคือเราอยากไปใหญ่กว่านี้แต่ว่ามี space เราชอบทำอะไรที่มันเป็น step by step นะมันก็แต่ตอนแรกก็เนี่ยเริ่มจากโต๊ะเดียว200 ตารางเมตร 2,000 ตารางเมตร 5,000 ตารางเมตร10,000 ตารางเมตร 20,000 ตารางเมตรผมคิดว่าอันต่อไปโรงงานเราFactory 3เนี่ยน่าจะประมาณ 20,000 ตารางเมตรขั้นต่ำ
ค่ะโอเคค่ะ
ครับอยากจะถามคุณเอิญด้วยนะครับเห็นเมื่อกี้ทางคุณเจมส์เนี่ยพูดไปแล้วถึงเรื่องแบตเตอรี่ต่างๆเนี่ยอยากจะทราบว่าทำไมถึงเลือกระบบ power system หรือว่าระบบ communication เนี่ยที่เป็นหัวใจหลักของการพัฒนาดาวเทียมของเราครับ
ครับขอบคุณครับก็พลังงานเนี่ยเป็นสิ่งสำคัญของไม่ว่าจะระบบใดระบบหนึ่งไม่ว่าจะเป็นระบบที่ไม่มีชีวิตหรือระบบที่มีชีวิตนะครับผมก็ถ้าเรามีพลังงานเยอะเนี่ยเราสามารถทำอะไรได้หลายๆอย่างมากขึ้นแล้วปัจจุบันเนี่ยเทคโนโลยีต่างๆที่ทำให้ระบบพลังงานของระบบดาวเทียมหรือระบบยานอวกาศต่างๆมันสามารถฟังก์ชันได้เนี่ยส่วนใหญ่ก็จะโฟกัสไปหาทางแบตเตอรี่แล้วก็ตรงโซลาร์พาวเวอร์ครับผมซึ่งการที่จะการ improve ให้power ตรงนี้มันเยอะขึ้นเรามีพลังงานมากขึ้นเนี่ยเราสามารถจะโฟกัสการใช้งานของลูกค้าการใช้งานของตัวเราเองไปหาลูกค้าได้มากขึ้นครับผมแล้วก็ปัจจุบันเนี่ยการใช้งานในวงโคจรดาวเทียมในโลกนะครับผมมันไปในทางทิศทางที่เป็นการใช้งานทางการสื่อสารการคอมมิวนิเคตต่างๆซึ่งด้วยการสื่อสารที่เป็นวงโคจรรอบโลกเนี่ยมันต้องใช้เทคโนโลยีที่เปลี่ยนไปมากขึ้นให้ความถี่ย่านความถี่สูงขึ้นให้มี power สูงขึ้นให้มี data rate เพิ่มขึ้นมีความเร็วในการสื่อสารมากขึ้นเนี่ยมันก็เป็นจุดโฟกัสที่ระบบดาวเทียมเราเนี่ยเราให้ความสำคัญกับการพัฒนาทั้งในทีมแล้วก็ในส่วนของชิ้นงานส่วนของโปรดักที่เรา develop ขึ้นมาด้วยครับผม
เสริมพูดได้ว่าจริงๆแล้วตรงนี้มันโฟกัสมาเราบอกเราคัสตอมสำหรับตัว specific needs เพราะว่าจริงแล้วทางเรามีการ develop ตัว subsystem ต่างๆนะครับแต่ว่า2ตัวที่เราได้รับความสนใจแล้วก็เวิร์กมาตลอดเนี่ยคือตรง power system กับตัว communication อันนี้เป็นสิ่งที่ทาง customer จะมองเราว่าเราแบบคือมันสูงกว่า peers ก็คือมันสูงกับตัวที่ available ในตลาดนะตอนนี้ผมพูดถึงทั่วโลกนะครับแต่ว่าของเราก็จะมีในเรื่องของว่าเรากำลังเร่งที่จะเพิ่มตัว output ของเรานะครับอันนี้ก็ทำไมถึงเราถึงต้องมี factory 2 เข้ามานะครับเพราะว่าเราเห็นแล้วว่าเทรนด์ปีหน้าเนี่ยมันมีโอกาสที่เราจะเรียกได้ว่าคือ capacity output เราเนี่ยจากออเดอร์ที่เราจะได้รับปีหน้าเนี่ยมันน่าจะเต็มครับ
ครับ
ค่ะโอเคต่อไปนะคะในเกี่ยวกับเรื่องด้าน business กันบ้างนะคะตอนนี้บริษัท MuSpace เนี่ยได้วางแผนในเรื่องของกลุ่มลูกค้าเป้าหมายในกลุ่ม Southeast Asia เป็นหลักใช่ไหมคะอยากทราบคุณเจมส์ค่ะว่าเห็น potential อะไรในตลาดอะค่ะ
ครับคือ Southeast Asia เนี่ยเราเห็นส่วนใหญ่แล้วเนี่ยมันไม่มี vertical integration company นะครับคือส่วนใหญ่ก็จะเป็นลักษณะคือซื้อมาขายไปก็คือเหมือนว่าไปเอามาจากต่างประเทศอันนี้ก็คือว่าก็ทำให้เราเรียกว่าจ่ายแพงกว่าที่ควรจะเป็นนะครับและอีกอันหนึ่งที่หายคือว่าเป็นเรื่องของตัวเขาเรียก community ด้วยหรือว่าการ support ในเรื่องของตัว employment job number ด้วยในการจ้างงานนะครับก็งานทางด้านเรื่องของเราเนี่ยเป็นงานไฮเทคนะครับซึ่งเราอยากมีตรงนี้เพิ่มมากขึ้นก็การที่เราเสิร์ฟลูกค้า Southeast Asia นอกเหนือจากว่าลูกค้าเนี่ยจะได้ใน Southeast Asia เนี่ยจะได้ตัว product ที่ดีขึ้นกับราคาที่จ่ายแล้วเนี่ยอีกอันหนึ่งก็คือว่าก็จะมีเขาเรียกว่า ecosystem ก็คือแบบพวกน้องๆเก่งๆรุ่นใหม่ๆเนี่ยก็ได้ทำอะไรที่มันยากๆนะครับก็อันนี้ก็เป็นผลดีนะครับก็เราก็ได้แรงสปอร์ตที่ดีจากต้องบอกว่าจากใน Southeast Asia เลยตั้งแต่ในประเทศไทยเราเองที่ทาง BOI ใช่ไหมก็ส่งเสริมนะครับแล้วก็ตอนนี้ก็มีทางออสเตรเลียเข้ามาด้วยอีกอันหนึ่งที่ว่าถ้าเราสามารถจอยอันนี้อาจจะแชร์ไปเลยเพราะว่ามันมีเรื่องการใช้ทรัพยากรหนึ่ง vertical integration มันดีลกับพวกเขาเรียกว่าพวก raw material เยอะอันนี้ก็จะมีส่วนที่เราอยากจะจอยตรงนี้เข้าด้วยกันก็หวังว่าก็จะสร้างเขาเรียกว่างาน income ให้กับ community ด้วยอย่างมี space เองเนี่ย factory 1 factory 2เนี่ยเราอยู่ตรงแถววิภาวดีใกล้สนามบินดอนเมืองเราก็จ้างเรียกว่าอาหารแม่บ้านทุกอย่างอะไรเงี้ยเราอยากได้คนในโลโก้เพราะว่าเราอยากจะแบบไม่ใช่แค่เหมือนกับพูดในเพรสสื่อว่าแบบอะไรเราอยากทำจริงก็เลยอันนี้เป็นโกของเราที่เราแบบอยากใช้แบบตรงไหนที่เราอยู่เนี่ยเราอยากให้คอมมูนิตี้มันดีขึ้นคนที่อยู่ตรงนั้นงานมันอยู่ที่ดีขึ้นเซฟตี้อะไรต่างๆคือทุกอย่างมันต้องพัฒนาอะไรเงี้ยและนี่เลยเป็นคีย์หลักว่าไอ้ vertical integration ของ MuSpace เนี่ยคือช่วย
ค่ะโอเคค่ะ
โอเคครับสุดท้ายนี้เนี่ยอยากจะให้คุณเจมฝากอะไรสั้นๆถึงแฟนๆของ MuSpace หรือว่าผู้ติดตามหรือว่าผู้ที่สนใจในเรื่องของอวกาศเรื่องของ Aerospace หน่อยครับ
ครับก็ Space ตอนนี้ก็ excited มากนะแล้วก็เทคโนโลยีโอกาสเนี่ยก็เกิดขึ้นแล้วไปเร็วมากนะครับคำถามคือว่าเราต้องเริ่มสักจุดเราต้องเริ่มเลยนะครับส่วน MuSpace ก็อย่าง4 ปีที่แล้วเนี่ยมันก็เป็น decision ที่แบบตอนนั้นก็เป็น decision ที่เราต้อง make ที่ทำ MuSpace นะครับก็อยากให้ถ้าฝากกับแฟนๆก็ถ้าได้มอง MuSpace ก็ support MuSpace นะครับ MuSpace ยังทำอะไรได้อีกเยอะนะครับแล้วก็เห็นว่าปีนี้มีเรื่องของตัว Space Travel ด้วย Human Space Travel ที่เราเห็นบริษัท Space ต่างๆเนี่ยได้ทำนะครับคือ goal long term goal ของ MuSpace เนี่ยคือเราต้องการจะเรียกว่าไปหาทรัพยากรบนดวงจันทร์นะครับอันนี้ก็ภายในเวลาที่เราตั้งไว้นะครับอันนี้ก็ยังเป็น first 2-3 สเต็ปแรกๆที่เราทำนะครับก็อยากให้ฝากติดตามแล้วก็ฝากบอกต่อแล้วก็ถ้าเจอทีมงานบางที่ก็อยากจะให้แบบสนับสนุนนะครับเพราะว่าจริงๆทีมงาน MuSpace เนี่ยเป็นคนรุ่นใหม่เยอะนะครับแล้วมีความสามารถสูงนะครับแล้วก็อนาคตไกลก็อยากจะบอกว่าเนี่ยมีจุดเนี้ยที่อยากให้ซัพพอร์ตทางคน MuSpace นะครับในไม่ว่าจะด้านอะไรก็ตามครับ
โอเคค่ะวันนี้ก็ขอบคุณคุณเจมส์แล้วก็คุณเอิญมากเลยนะคะที่มาร่วมพูดคุยกับเราในวันนี้ค่ะก็สำหรับพวกเรา4 คนนะคะก็ขอบคุณแฟนๆทุกคนที่ติดตามพวกเราตลอดนะคะแล้วก็ฝากช่องทางโซเชียลมีเดียของ MuSpace ด้วยนะคะ @MuSpaceTech นะคะสำหรับวันนี้พวกเรา4 คนลาไปก่อนค่ะสวัสดีค่ะ
สวัสดีครับ
สวัสดีครับเสร็จยังผิด